Today we're going to look at absolute value problem. Absolute value falls under further studies in mathematics. In some context, we can bring in the more simple ones into core as well. Here we have a problem. We are asked to solve for p if absolute value of p plus 2p is equal to 5. We need to understand the foundation of absolute value. Absolute value bar, whenever you have absolute value bar, the rule is that whatever you have inside can never return a negative value. So absolute value of negative 2 is 2, absolute value of 5 is 5. So whatever you have inside, whether it is positive or negative, can only return a positive value. So we have two conditions, and those conditions are what gives the foundations of absolutes. They give the foundation of everything we do under absolute value. The first condition is that whatever you have in the absolute bar will be a positive. Whatever you have in the absolute bar can be a positive. Whatever you have also in the absolute bar can also be a negative. But irrespective of what you have, it's supposed to return a positive value. So we consider all options, whether it is a positive or negative, it will return the same. So we will use this to simplify the expression and then solve for them done. Now the first thing, we have p plus 2. So p plus 2 can either be a positive or p plus 2 can be a negative value. If it is a positive value, let's get the expression that we solve. Then it is p plus 2, which is a positive, plus 2p equals to 5. Then if we solve p plus 2p is 3p, and then 5 minus 2 if we collect like terms is 3, then in this case, p is equals to 1. In this case, p is equals to 1. What do we do? Let's check for critical values. We check if this value is going to be valid for this. If we have p as 1, and 1 plus 2 is 3, plus 2 times 1 is equivalent to what we have on the right hand side. Absolute value of 3 is 3, plus 2, that is 5. So p equals to 1 is valid. Now, if p was a negative value, if p plus 2, what we have in the absolute value, was a negative value, we will return negative of what we have inside. Remember, for it to be positive, it could have been a negative or a positive. That means two options. It will still return a positive. So if it was a negative second condition, then we have this in the expression or the equation. Then this will give us negative p, negative 2 plus 2p equals to 5. Now, negative p plus 2p is p. And then 5, this is minus 2 plus 2 becomes plus, is equals to 7. We also need to check for critical values that are valid. If p is equals to 7, we have 7 plus 2 is 9. 7 plus 2 is 9. Absolute value of 9 is also 9. Plus 2 times 7 is 14. Now the question is 2 times 7 is 14. Now the question is, absolute value of this is 9. 9 plus 14, is it equivalent to 5? 9 plus 14 is actually 23. So, what they're telling us is that the value inside here couldn't have been a negative, because for this, it would not be valid. For this, we can say that this is not valid, because p cannot be 7 and still satisfy these conditions. So, for what we have here, it can never be a negative value in the absolute value bar. So, this is how we solve for absolute value space. It is very important that you check, because these conditions must be met, and we need to check if these conditions are valid. In some cases, both of them will be valid for the given expression. In other cases, they may not. This is how we approach absolute values. If you have any question, please shoot, share, and comment. I will see you. Have a good day.